So we're underneath the house, and we know we have some significant foundation issues. The house has been settling on the north side, and coming underneath, we see that we have some, I guess those are pier and posts. So we have a post and beam structure here, but it's really just cinder blocks and bricks. And they've just been wedged up. So there's no concrete footer. But I do notice we have new joists, so that's beneficial. However, most of our insulation in these bays have fallen out, and we need to re-insulate. However, I'm not going to re-insulate and crawl under here until we get adequate footers, a little bit more similar to this concrete footer. Also, your post should not be in contact with your masonry, so we'll need to correct those. And then you can see here that there is no girder sill plate going across the whole north side. It's just been floating on these girders. So they've sagged, which means we need to jack them back up. And to do that, we're going to use some bottle jacks. So let's crawl up under here and see what's going on. I've been down here trying to get us somewhat temporarily stabilized, but when you get an old house, this is what you get. Luckily, some of this has been addressed in a temporary fashion already. It's not going to suffice. And we have a problem with our access here because I am on my belly. And we have roughly 18 inches of workspace. And you can see there, the house, this girder foundation is actually just a boulder that they couldn't remove when they built the original house in 1945. So that one was notched out, and believe it or not, is one of the most solid parts of the foundation. So what we need to do is we need to get under here, excavate, and we also first we need to get access because we can barely work under here. time-lapse video of the kitchen remodel where we dropped the ceiling and we did the cathedral ceiling. There was a part in there where I had the laser up and you could see, I think it was a 5 1/4 inch difference in the drop from the center, from the corner of the room to the other corner of the room. And so we've excavated out and we had to get up under here because, well, architecturally speaking, I don't know what is going on with this foundation. It's probably most likely 4 different repair jobs over the course of 80 years. So I'm not really sure exactly how this all stacks up, but we moved a crap ton of rock. We still have one girder that is resting on a rock foundation, and that's just going to stay for now, because right now our concern is remediating the problem with the girder on this. I'm going to call it a pier and post system. It's kind of more like a dirt foundation, rocks piled on wood setup. I don't know. Anyway, so check this out. So after we got the floor up in the interior and we're able to see down in there, I realized that this excavation was going to go further than it needed to. We have our level line shot here. It's just a level line, it's just a reference line. It's our control, and everything's on a slope, and it's all either glacial till, hard pan, or complete clay. So I don't know how well this is going to show, but I'm going to post this because I have been filming, but I have a whole spring and summer of video to edit, so I don't know when it's going to come out, but when the rains come and it starts getting cold, I'll be inside editing. Right now I'm going to race before this turns into a moat to get this filled in. So as you can see, this is all clay. We went down as far as we feasibly can at this moment. This is actually not going to be the final exterior foundation. This will actually be a center pier. But just check this out. So it did come in. It is pressure treated, so I know this was the 2000, so 2000 renovation. But we have some posts, and then here's where it gets really tricky. So there were big boulders right here, giant boulders, and I got them out. We're just using the demo hammer and the clay spade and some levers and fulcrums. But anyway, we added the stone. We got the footer foundation. We're a little wider than is minimally required, but we are not as wide as I require. However, we're just running out of space here. I could come out further, but it's not going to benefit us as far as the load's concerned. Like I said, there's going to be another footer to the north of here, another 6 to 10 feet something. So check this out. So here you have, these are your 2x4 floor joists. So that's insufficient in my book, but sitting on 4x6 pressure treated, that's good. It's on a masonry pier. This is actually turned the wrong way if it was even to be used that way. It's structurally not, this is not the structurally correct way to place these blocks. It's probably good because the water could pass through, but other than that, it's absolutely non-structural that way. So yeah, anyway, so then it's going to start to disappear here because it actually goes very far under, because it's as far as you could get because of the boulders that were here that I had to excavate. So we're coming in, right? And now we have, this is where the first door was. The original door was right here. So this was added, right? So I thought we had a sill plate and it just cracked. The sill plate is actually attached to the ends, or sorry, the girder is attached to the ends of our floor joists. So any load on this wall, all the way up, all the load is determined by the shear strength of the screws that are
toenailed into these joists. And that's why now I realize when I was jacking up the building from underneath, why I wasn't getting any of the wall movement. I was getting joist movement and floor movement, but no wall movement, because the wall weight is actually floating on this. And there was nothing here. I didn't have to excavate anything. It was just air. So unfortunately, that's only a 3-foot section. And then we have another 3-foot section. This 3-foot section is doing the exact same thing. It's just attached to the ends of the studs like a fascia board. And so again, the weight of this wall is resting on the shear strength of the screws attaching this fascia girder. It's not even a term, but stick with me here. And on top of that, it's only 3 feet, and then there's a break, and then there's 3 feet, and then there's virtually nothing. And then the girder that is down here is actually about 4 feet into the structure. So the whole bottom of this wall, as the load comes down, it's bowing out at the bottom. And then, so the load is both going down and out, which is not a huge deal. We have it braced on the inside and we have it braced on the outside. It's just going to be a really, really tricky replacement of this, and a little switcheroony for the jacking. So I have to keep the existing piers here. Ideally, when I'm doing a foundation, we'd want to have the full run as a monolithic pour, so that the strength of the concrete is as a whole and not in its segments. Unfortunately, I had to go with the middle road here, and what we're going to do is we're going to pour the section of the footer that we need here. So this is the width of the footer. This 20. We went with 20 inches. I just went with 3/8 rebar, and then I did 4 tie-ups, 4 rows, 2 chairs. But then what I did on the ends, you see that nasty grate stuff. I love it, but it's stickier than all hell. So what we're going to do is we actually just punch some holes through our end boards. These are going to just allow us, and then I've grate stuffed them. And so even though my pour is not going to have continuity, my rebar will. And it's just the best I can do. I have to keep this pier. I have to keep that pier. It's carrying whatever load, and I can't jack anything because there's nothing to jack. It's attached with screws. So I have the interior wall out, and we're jacking up, and then I have exterior wall jacks. And then what we're going to do is I'm going to take this out and then see how much of a drop I get off of my level line or control, and how much of a drop. If I get a lot of drop, then I've got to do the girder in after the footer, and then the support wall is poured. Then I'm going to have to do half a beam and then jack it up, and then half a girder and then jack it up. So it's tricky. It's a little unorthodox, but in historic preservation and construction and remodeling and old homes, it's par for the course, and you have to be a little flexible, know the codes, also kind of be willing to be a little creative in your solutions. So it's half construction, half creative problem solving. But ideally, what this will do is this will give us a central beam that I know the house won't be settling anymore. Then we can go in and we can deal with some of the rot once we know where our load is getting carried, and the water is going to be dealt with, because we'll have solid foundation, we'll have concrete pier, and then we'll have the drainage pipe right here with our drain, so the water will go out, so we know we won't